Hey guys, all right, so let's get to the 16.2 homework, numbers 5 through 11. So number 5, we have to solve for x, and it says to solve for x to 3 decimal places. So we have 8 to the x equals 100. So the base on that exponent is an 8. So to get the x out of the exponent, you need to take a log base 8 on both sides. That way you can get the double base to cancel out, and then x can come down, and we'll have log base 8 of 100 on the other side. And then remember, we're going to need to use the change of base formula, so log of the input over log of the base, and then you type that into your calculator. Lucas, get out, please, and close the door. No, get out, please. Get out, please, and close the door. Get out, please, and close the door. Oh my gosh. Okay. So to 3 decimal places, it'll be 2.215, because that's a 6 after the 4. 5 or higher, you go up 1. All right, and there we go. Okay, next one, number 6. We have 3 to the x minus 4 equals 85. We need to solve for x. It's in that exponent again, so I have to get it to come down. So I need a double base. So I need to take the log base 3, since this is a 3, on both sides. That way I can get the double base to cancel out, and then the exponent, x minus 4, can come down, and we'll have log base 3 of 85. Now I need to add 4 to both sides, so I'll do that. At the same time, I'm going to change this to the change of base formula. So log of 85 over log of 3. Remember, the base is always in the bottom, and then don't forget the plus 4. So we're going to type that into our calculator. So, and I use this calculator because it's easier and it's my favorite. So log of 85 divided by log of 3. If you guys need me to see the other calculator though, just ask. Equals, and then plus 4 equals 8.044. Okay. Number 7. 3e to the x plus 2 power equals 87. Well, I need to isolate the exponential term, so we got to get rid of that 3. It's in front of the e, so that means it's being multiplied, so we have to divide. And we get e to the x plus 2. Does 3 go into 87 evenly? I'm not sure. Oh, it does. 29 times. I wouldn't have known that. It's not a typical number that we deal with. All right, I need to get the x plus 2 out of the exponent, and the way to do that is to get a double base. So what has a base e? Well, that would be the natural log, because it has a base e that's not written. I don't need to write the base e. I'm writing it here so I could have the double base so you could see it cancels, but you don't have to write the base on a natural log. Just know that it's an e. So x plus 2 equals natural log of 29. What's nice is we don't need to change a base formula for natural log because we have a natural log button. All right, and we got to subtract 2 from both sides. So x is going to be whatever natural log of 29 minus 2 is. So ln natural log of, was it 29? Yeah, 29 equals minus 2 equals 1.367. Number 8. This one has a little bit more meat to it. We have to isolate the exponential term. So I have to get rid of that plus 7. So I have to subtract the 7 first. So we have 2 to the 3x minus 2 power. 25 minus 7 is what, 18? Yeah. And now that this is isolated, I have to get the exponent out because that's where the x is. So it's a base of 2, so I have to take a log base 2 on both sides. Double base cancels out, the exponent gets to come down, and we'll have log base 2 of 18 on the right. I need to add 2 to both sides. So I'll get 3x equals, I'm going to go ahead and change this to the change of base formula because I'm going to have to enter it in my calculator soon. Plus 2. And now to get rid of that 3 in front of the x, we're going to have to divide by 3. So I'm just going to write it like this, and then we'll put what it equals. So I have to go in order in my calculator. So what's nice about this one, like I've been telling you guys, is you get to type it in the way you see it. So I'm going to type this in first. I'm going to hit enter. I'm going to plus 2, hit enter. I'm going to divide by 3, hit enter, and then I'll have my answer. Okay, so I'm just doing one thing at a time. So log 18 divided by, it was log 2, enter. And then add 2, so plus 2, enter. Divide by 3, enter. So 2.057. See all these steps that are involved? I should see all those kinds of steps. Okay. All right, number 9, we have 2 times 4 to the 3x power minus 3 equals 27. So I've got a couple things that I need to move, like this minus 3, because we have to isolate the 4 to the 3x. So I'm going to add 3 to both sides. I'll get 2 times 4 to the 3x equals 30. I need to divide by 2 to get rid of it on both sides. So I'll have 4 to the 3x power equals 15. Okay, now it's isolated. The 4 is the base on that exponent, so I need to take a log base 4 on both sides. Double base cancels, 3x gets to come down. And I'll go ahead and switch this to the change of base formula. Log of 15 divided by log of the base, which is 4, because base always goes in the bottom. And then I got to get rid of that 3, so I got to divide by 3. I'm going to write it like this, and then we'll just put the answer since I'm out of room again. So I'm going to hit log 15 divided by log 4. I'm going to hit equals, and then I'm going to divide by 3 and hit equals, and then I will have my answer. So log 15 divided by log 4 equals, and then divide by 3 equals 0.651. Okay, number 10. All right, we got to get rid of that negative 1.5 because we need to isolate the exponential terms. So we got to add 1.5 to both sides. So we get e to the 2x equals 7 plus 5 is what, 12, 6, 7, 8, 8.2. Okay. All right, the exponential term is isolated. It's an e, so the kind of log we have to take on both sides is a natural log because natural log has base e, and I need that double base so that the 2x can come down. And we'll have the natural log of 8.2. All right, I got to solve for x. I have to divide by 2 on both sides. And so x is going to equal whatever this is. So I'm going to hit natural log of 8.2 equals, and then I'm going to divide by 2 and then hit the equal button. So natural log 8.2 equals, I guess I could have put divide by 2 also on the same screen, but sometimes it's better to separate it just in case you type it in wrong. So 1.052. And that was number 10. Okay. Number 11, let's go ahead and read it. It says a deposit of $4,000. Okay. We're depositing $4,000, so that's the principal, is made into a savings account that pays 2.48 annual interest. So that is the R, the rate. It says compounded quarterly. So there are 4 quarters in a year, so N equals 4. How much money will be in the account after 3 years is part A. So T equals 3. So we're using the regular compounded interest formula because it tells us the number of times it's compounded. And so we'll start with A. We'll come back to this. So I have it already ready to go on another piece of paper. Okay, so I already have the principal amount. I have the rate written as a decimal. This is the given information. The number of times it's compounded is 4. And for part A, they want to know how much money will be in the account after 3 years. So the formula we have to use is the compound interest formula. This one right here, I highlighted. It's the same one right here. It's just twice. So I need A equals P times 1 plus R over N to the NT power. So I need that. That's why it's important to have your notes around with you because you don't memorize these formulas. You have them where you can find them so you can use them. Okay, so let's plug in what we know. We're trying to find the amount in the account after 3 years. So we're trying to find A. We know that the amount we're starting with, the principal, is $4,000 times 1 plus the rate is 0.0248, and the number of times it's compounded, N, is 4, to the 4 times the number of years is 3 power. Okay, so let's clean this up because, yeah, we are going to be typing this into our calculator, but we want it to be as seamless as possible so that it's the easiest as possible to type it in. Notice I left the parentheses blank for right now because I'm going to need the calculator to simplify that next part. So before I can add, I have to divide this, the 0.0248 divided by 4. Okay, and then I have to plus 1. So 1.0062. Okay, now in this calculator, I could type it in the whole thing and hit equals and get my answer. Now, if yours is different, you need to do it piece by piece. So even though I can type that whole thing in all at once, I'm going to do it piece by piece. And because some calculators make you do that anyway, you need to make sure you're following order of operations. So we have to take care of the exponent first. So 1.0062 to the 12th power, raised to the 12th power. And I get this number. I'm going to keep that in my calculator because I just figured out what this is. Now I need to multiply by 4,000. So times 4,000 equals this amount. So that's 4307.96. So after 3 years, he's going to have $4,307.96, which means that he earned $307.96 in interest and free money just for using that bank. Okay. Letter B. I put earn 500 interest. What does it say exactly? How long? Okay, so we want to figure out how many years it's going to take for the account to earn $500 in interest. Okay, so if it earns 500 in interest and you put 4,000 in initially, that means it's going to have $4,500 when it earns 500 in interest. Okay, so we know the amount, we know the principal, we know the rate is still the same. What we don't know, and we know it's compounded quarterly, what we don't know is the time, okay? So we're using the same formula here. So I'm just gonna plug it in. A is 4,500, P is 4,000, and then the R and the N are still the same. So 1 plus R over N is still gonna be the 1.0062. So no need to do that math again. We already did it. And then this time to the NT power, I don't know T this time. I only know N, so it would be just the 4T power. We need to solve for T, but we learned how to do that in this lesson, okay? First step, we need to isolate the exponential term. So I need to get rid of that 4,000. It's in front, so it's being multiplied. So to undo it, I gotta divide. Okay. I've got zeros. You guys know I like those. So I have 45 over 40. I think I'm going to want this as a decimal. So let's see if it's a nice one. 1.125. Perfect. It's nice and small. That's what I like. Okay, so we got 1.0062 to the 4t power. All right, now I need to get the t out of that exponent. So to do that, we need to take a log of a certain base on both sides. Well, the base on the exponent is the 1.0062. So I have to take a log base 1.0062 on both sides. Yeah, you have to write it. I know it's long, no big deal. The double bases cancel and then the 4t gets to come down. And then on this side, I'll use the change of base formula. We'll have log of 1.125 over log of the base, 1.0062. Okay. All right, I don't like it this way. It looks weird, so I'm going to flip it like a pancake. Log of 1.125 over log 1.0062. All right, I still need to solve for t, though, so I'm going to have to divide by 4. So I'm going to write it like this, and then we'll put the little squiggly equal sign, okay? So in my calculator, I'm going to type in log of 1.125 divided by log of 1.0062. I'm going to hit equals, and then I'm going to divide by 4 and hit equals. So log of 1.125 divided by log of 1.0062 equals, divide by 4 equals 4.764. So approximately, if we round up, 5 years. Now, if you left it 4.764, that's fine too, okay? But we usually round up for something like that. You don't tell someone, oh, it's going to take you 4.764 years to do this. Like, no, you don't talk like that. Okay. I know it's kind of nerdy, and maybe you think that nerdy people talk like that, but we don't. We do when we're joking. All right, now letter C. Let's see what the instructions say on that one. It says, how much more money will be in the account after 3 years if the interest is compounded continuously? That's a different formula, instead of quarterly. So the continuously compounded formula is this one, A equals PE to the RT, my PERT plus formula. A equals PE to the RT. And I not only have to find the amount in the account after 3 years, but I also need to see how much more this one is going to be than the first one that we did. All right, so let's see. We don't know the amount. That's what we're trying to find. The principal, the amount we're putting in is 4,000. E, I guess I didn't need parentheses, whatever. To the RT power, the R was 0.0248. And the T is 3 years. Okay. So for this one, I'm going to need to clean that up a little bit before I put everything in my calculator. So 0.0248 times 3, 0.0744. It's not going to kill you to have to write it again. I'm not going to write the parentheses again, though. So I didn't need them the first time. Don't know why I did it. I guess force a habit. Okay, so now in the calculator, I'm going to do it piece by piece, even though in this calculator, I could type in the whole thing all at once. In the other calculator, the one I was showing you in the videos, it's right here, this one, you can't do that. You have to do it piece by piece, okay? So first of all, second E to the 0.0744. Now, why did I start with that? Because that's the term with the exponent, because you have to do exponents first, PEMDAS. Okay, so I get this number. I'm going to keep it there. I need to multiply by 4,000. So 4308.95. Okay, that's not the answer they wanted, though. They want to know how much more money is this one going to get than this one. Well, it's not much more, right? But how can I figure how much more? You subtract them. So 4308.95 minus 4307.96. I know I wrote it like I'm going to do it by hand, but no, I'm not. Why do that when I have a calculator right here? The point is to show you that you got to write it down. 99 cents more. So if it were more years in the account, it might pay off a lot more. But right now, they're so close. It's only 99 cents more. So, I don't know. What choice would you make? Although this formula is an easier formula. But this one's compounded more. So if you decided to pull your money out sooner than the 3 years, you would have a better chance of getting more money than this one. So it just depends on what you want to use the account for, really. All right, that's it, guys. Have a good one.